right? Probably no one else managed something like this. So we have like 500 CPU cores, 21 GPUs, like 56 gigabyte bit per second InfiniBand interconnect, and like 19 gigabyte storage throughput. So it's a pretty good cluster for our size. It's pretty good, right? It's not a national level, right? But it's pretty good. Now, why do we have this, right? As I said, it's very rare for a department to have something like this. The reason is that we have the pandemic. And during the pandemic, we have complete remote teaching, which poses a problem, is that how are we supposed to let students get access to the software they need for homework and projects, right? In the past, they just come into the computer lab, physical computer labs, and problem solved, right? But during the pandemic, we couldn't do that. So we built the cluster over summer in anticipation that we would have to go to full remote teaching. And we did, for longer than we expected. So because we have to support teaching, not just research, ease of access is a core consideration. This is the main difference between what we run versus like a typical university HPC cluster, is that we need really it works on everything. So what's that? That's Jupyter. Jupyter is probably the most mature platform for such kind of use. Now, isn't Jupyter for Python? Well, no. Jupyter's language agnostic, actually. You actually have native Jupyter kernels for R and Julia, right? So these are actually, there's zero Python code in these Jupyter notebooks, right? Kernels. Like, everything is written natively. There are also kernels written in Python for other languages, such as MATLAB and Stata. So these are actually, the kernel is Python, but it just calls the software to run the code on those software. Right, so these all use the Jupyter Notebook interface, right? And what if the user wants the language native GUI, for example, our studio? Well, that's where Jupyter Server Proxy comes in. Now, let me just, for a brief moment, demonstrate what we have, right? So this is our what we call a login node in a cluster. So this is a public accessible URL. You click on Jupyter. The students sign in. Every student get an account at the beginning of the term, and you sign in. It just looks exactly the same as the Jupyter if you would have your own computer, right? But it's running on our server, right? So you have all these environments that we manage for them. They can also install their own environment. This is what we manage now. Let's take MATLAB. Actually, MATLAB is a bit slow. Let's take our studio as an example first. Now, this is if you click on the icon I took just now, R, this is a native Python kernel. Native R kernel. So you can run R code on it. So I'm just going to copy like eigenvalue decomposition. That's like a simple one, right? So this is to manage a multi-user environment. So you can do it in your own computer, but if you want to do it over the web, then it's not something that is built in. So you need something else to handle the user login, right? MATLAB itself, it takes a long time to launch, even if you're using it natively on your computer, but it does work. This is MATLAB GUI running over a browser, right? All right, so it does work. It works. So how does this work? This works through something called Jupyter Server Proxy. How does that work? Now, let's contrast a notebook versus a proxy. Jupyter Notebook runs like this, right? In our case, we are running Jupyter Hub because we are having a multi-user environment. Jupyter Hub handles login, authentication, and the spawning of single user server, right? So there's communication between the two. The single user server, in turn, would launch an individual kernel, right? An individual notebook kernel. Now that's how standard Jupyter works, right? Including Python, right? There's these steps involved. In Jupyter Server Proxy, you have Jupyter Hub handling the user authentication and the spawning of the single user server. Then the single user server, through Jupyter Server Proxy, is going to communicate with the software you're intending to use, right? So through this mechanism, you can actually use Jupyter to launch MATLAB or Stata or pretty much any software right? The requirement is, though, that for the software to work like this, it has to have a native browser-based GUI, because Jupyter Server Proxy is just a proxy. It doesn't actually create the interface. It's not VNC or anything, right? There must be a native browser-based GUI, like R Studio. Furthermore, the Jupyter Server Proxy only provides the app launching and communication framework. It's a framework. The actual launch command needs to be separately implemented in a Python package, right? So you can think of this is like a lower level thing, right? Then you need to build on top of it. And how does that work? Right. So generally, what you need to do is to write a proxy package, like a Python package that implements how the application is supposed to be launched, right? So the package really, it's very simple. You'll see in a moment in the examples I show you. All it needs, the most important thing it needs to do is to return a dictionary, a Python dictionary, that contains the command to launch the instance of the software. And because this is so why does it has to be a Python package? Because the way Jupyter Server Proxy knows that there is something that it needs to handle is through entry points in the setup.py of the proxy package, right? So that's why every time you want to add this new thing to your Jupyter launcher, right? Then you have to write a new package, because you need setup.py to have entry points, right? I'm going to show you in a moment how that works. So we're going to just take a look at two examples: Jupyter R session proxy that handles R, and Jupyter MATLAB proxy that handles MATLAB. Now let's take a look. Right. Okay. So right. Now this is Jupyter R session proxy. This is what you would install if you want to run R Studio in Jupyter, right? If you just want R, you can just use the native IR kernel, which, as I said, launches a notebook. But if you want R Studio, the whole GUI, then you need Jupyter R session proxy. The code is extremely simple. First, setup py. So setup.py. Okay, the only thing that's most important is actually, as I said, there must be an entry point. This entry point for Jupyter Server Proxy servers that points to the module and the function that actually returns the command to launch the application, right? So Jupyter R session proxy : setup R server, right? Let's take a look at that. That's here. This is it's inside init.py. Let's go. Right? The function is here. Setup R server. This is the function, right? This is the function. This, once again, this function is going to return the command that launches R Studio, right? All right. So most of the things it concerns is finding where R is, right? Finding where R is. It then returns a dictionary, right? So it's going to return server process, and server process is a Python dictionary. And this dictionary has several things it has to specify. The most important of it is command. Pretty much all the other things you don't need if you don't want to. But command is necessary, because this is where it returns the location of R Studio, right? So itself, it's a very similar idea. This function is actually going to return the location of this MATLAB proxy, and in turn, MATLAB proxy, which is a separate Python package that is going to launch MATLAB, right? So there's this extra step in this case, right? But from the end user perspective, right, you basically what you want to do is for this function to return the location of a command, to return a command that can launch the web GUI of the server. And then MATLAB, and then Jupyter Server Proxy will handle all the communication for you, right? Okay, so that's what it does, right? And then with that, you have the ability to run native MATLAB, to run MATLAB GUI or R Studio through Jupyter. Now, once again, the reason why you have to do this is that you need Jupyter, right? If you're running on your own computer, you can just directly launch RStudio or directly launch MATLAB proxy. The reason you do that must be you need Jupyter. And most of the time, once again, it's because you're in a multi-user environment. In a multi-user environment, especially if you want them a way to access, then Jupyter handles user authentication plus resource management. Because these programs, MATLAB and RStudio, are now under Jupyter single user server's control. If you're using, for example, you're using system desponder, the system desponder, you can actually limit the amount of resource, like CPU, RAM, that is used by each of these programs, right? Natively, at least the open source version, don't have these features for RStudio and MATLAB, right? There's no way to control how much they use, right? Okay, all right, so on a computing cluster, it's actually very common to have multiple versions of a software available, right? This is very important for research because we want things to be replicable. So you actually sometimes very often freeze the versions of stuff you use. How do we implement that? Now, let's first talk about native kernel, right? If you're using IR kernel or any Python kernel, it's actually very simple, right? So for native kernel, like IR kernel for R, what you have to do is that it's all native R. So you just launch the version you need a Jupyter kernel, and then install the native package. So first, let's say I have R 4.2. I'm going to launch R 4.2 and use the native command in R to install IR kernel. Next, launch the different version of R. This time Microsoft R Open. Run the command again. Remember to give it a different name, right? Otherwise, it's just going to overwrite it. But as long as you have a different name, then now you would see 2 R version under your Jupyter launcher, right? But this is for native kernels. Next, like for kernels written in Python, that's even simpler. Just create new virtual environments, right? Just like any Python kernels, right? The only thing that's a bit more complicated is if the kernel actually needs to locate the software, like Stata, and it uses path to do that, then you would have to modify path, right? That's the complicated part. Now you can use conda develop. That will be an easy way. Conda develop, just add the path, and that will be done. That will be done. But you can also use a shell script to do that, right? You would have to manually create something inside activate.d and deactivate.d to manually manipulate path, right? This is kind of like what conda does, right? When you conda have add things to your bash RC, that adds conda itself to your path, right? The same idea. If you want to do this, you would have to do that too, right? But so this is probably harder, but it can be done, right? It can be done if you need to. What about the proxy packages? Now the proxy packages makes things complicated because it's so dependent on setup.py. You cannot modify setup.py afterwards, right? Which means if you want multiple versions, you would have to have multiple packages. And they don't make it easy. Well, they don't make it easy for you. They can make it easier, but they don't. No, it seems like an afterthought, right? So what you need to do is go to GitHub, fork those packages, right? Just fork it, mix several changes, right? So, okay, so what do you do? First, go to GitHub, fork it. There are 4 things you might have to modify. First, setup.py certainly have to be modified. The thing you have to modify is the Jupyter. So entry point equals to Jupyter server proxy servers. So there's something equals something. The thing that's on the left-hand side of the equal sign, this is the URL. It's going to be the URL, like this right here. You see this one? RStudio, or here, MATLAB, right? MATLAB. This comes from here. So this must be unique. This must be unique for every version of the software, right? Basically, actually, it has to be unique for every proxy, right? Because the user might, just like what I'm doing, the user might launch RStudio, launch MATLAB, and MATLAB version 1, MATLAB version 2 at the same time. If they have the same URL name, then it won't work, right? So this must be unique among every single proxy, right? So change that. usually just change it to something reasonable. The module, if you want, can be completely the same. Doesn't have to change, right? So next, inside module colon function, right? So inside the function that actually returns the command, first, you have to modify the path to the software, right? And once again, as I said, you can hard code this if you want, right? For us, right? We can just hard code this for our cluster because this is internal anyway, right? This is internal to our cluster. You might have to modify the environment because, as I said, some of the software like MATLAB proxy use the environment to locate the actual software. But this is easy because this is now all Python code, right? This is actually a Python package. You can use os.environ to locate the path, modify it, and the scope is completely limited to the launch of the software. Doesn't affect anything else. So this is actually, it's a bit inconvenient to set up. Unfortunately, they could have made things easier, and especially the way because so much stuff is hard coded. If you have to fork it instead of import it. Had they make these things if they make these things that you can supply to the function as an argument, right? Then you could just call this function, right? In your package, you can just call this function, and this it would be a really elegant solution because you just have to call this function. But right now, you have to fork it, and if they modify their code, you would have to merge in their changes, which is inconvenient, right? Yeah, but it can be done. It can be done in yeah. So right. So this is what I want to talk about in terms of how they work. Now, Scotty, when we talk about what I should talk about, he's also saying that if anyone is interested about running Python in a academic environment, especially in terms of teaching Python, I'm also very happy to answer questions about that. Well, the cluster is built in 2020, but yeah, we have been teaching Python for probably almost a decade, right? Yeah. So yeah, we'd be very happy to answer any questions on that too. All right.
Are there any questions from the floor?
What other languages other than R and I guess MATLAB is appropriate? I guess is suitable for
right. Now, the
questions from the floor.
Thank you.
Okay, so now in general, the most challenging part for MATLAB is actually licensing, license server.
Okay,
right. Okay, so this is something I didn't mention, is that if you install Jupyter MATLAB proxy, just like it is, right? Just pip install Jupyter MATLAB proxy, and even if you have MATLAB running, you would find that it's not going to work. The reason is that if you, in the case where you're using a license server like we do in the university, it just doesn't know where it needs an environmental variable set in order to find the license server. And, well, usually the way it works is on your server you have a license file that points to the location of the license server, and it needs an environmental variable set to find that. The problem is that if you set it in your overall environment, that's often not what's used by Conda, right? Conda does its kind of own thing, right? It might not actually refer to your environment. So you actually have to somehow set it here. And that means, once again, you probably would have to modify this package. In this package, once again, there is one part besides the command. You can also provide the environment this software needs. So this part, there's this get environment function in this Jupyter MATLAB proxy, and they return 3 of them. And they don't have a way. They didn't have a way here for you to specify the location of the license file. So you have to add one more line right here. You have to add one more line. So this is just a list. This is just a dictionary of the environment variable name and then the value. Just add one more line that use the correct environment name. I don't remember what that is, but the MATLAB has a very specific name for the location of the license file. Add that line, and everything will work. That's for MATLAB. For R, I think R itself is pretty easy to set up. I think the difficulty of R is actually choosing the version, right? Do you use MRO, Microsoft R Open, which is still on 4.0? Do you use the newest version, 4.2? Do you use the version from the official repository of your Linux platform? But that is usually not optimized, right? So for us, for example, we compound way of tricking it, which doesn't work in a new version. In a new version, there's another way of tricking it, which doesn't work in the old version. So you have to know the linear algebra library well. That's the hard part, and that's why we have this service. We handle all of that for our researchers and students. They don't have to think about it, right? We just make sure that everything is optimized. They just have to run it. So that saves a lot of time. They just concerned about their actual research, and we handle the technical details, right?
We can take perhaps one more question.
Yeah. Forgive me, this question is offensive. How reliable is this setup? Is there any crash recovery considering
the cluster itself or this?
Considering hundreds of students are using it, have any student managed to crash the system?
Okay, so we have so initially, when we first set it up, there's first a couple of hiccups. Now it's been running over 2 years. Yeah, never. Now, we still have a lot of the things that you're not supposed to need, right? This has to be redundant. We have daily offsite. We have hourly on-site backup and daily offsite backup to like free redundancy zone on AWS, right? So once again, as an individual user, that would be too much work for them. But for us, obviously, we do this once, and it's automatic for everyone, right? So we have technical staff that handles like a lot of the stuff that works, like UPS stuff, like power supply, how much power we need, how much cooling we need, right? We obviously have to consider that, right? So initially, as I said, when we first set this up, we did have a few crashes. What are the reasons? First, initially, when we initially set this up, we have a very small budget, right? This is a new project. We didn't have enough RAM. So when 200 students tried to log in, it crashed. So okay, we need more RAM, right? Second, we see when you run so calculating the power in this is actually really important, because as we add more GPUs and more cores, right, we are using a lot of power. So initially we're just kind of using wall sockets, even though we use multiple.
Are there any more questions from the floor? If not, I think we should thank Dr. Chow once again for his very inspiring talk.